Good day, everyone, and welcome to Flip Lectures in Chemistry. Today, we will be talking about how solutions are formed. What is a solution? A solution refers or is formed when two or more substances combine in such a way that one component cannot be distinguished from the other. The formation of solution involves a dissolving process. The process of dissolving one substance in another is considered a physical change. In a dissolving process, the particles of these substances are held together by intermolecular forces. These intermolecular forces also operate between a solute particle and a solvent that surrounds it. There is absolutely no chemical reaction in the dissolving process. The formation of a solution involves energy change, however, although it may be small. However, sometimes some attractive interactions are broken and others are formed during the process. So some are broken and some are formed. So in this process, where interactions are broken and formed, energy could be somehow lost or energy are sometimes gained. For example, in a solute attractive forces and solvent attractive forces, when they are broken down, and these processes would involve what we call an endothermic type of reaction. On the other hand, if we are given a solute solvent attractive forces, when these are formed together, this is actually involving an exothermic process. A solute may be molecular or ionic, with different forces involved with each other. A molecular solute separate molecules are held together by weak intermolecular forces. So we have the London dipole, the dipole-dipole, and sometimes the hydrogen bond. An ionic solute separate ions can either be positive or sometimes negative. And when this happens, when they are held together, they form ionic bonds. When dissolving occurs, these bonds must break, and the solute must bond with the solvent. That is why in the process of breaking and forming together of the different or of the solute and the solvent, we have the gaining and the losing of energy. The gaining of the losing of energy can be in the form of releasing or absorbing heat, and these are either your exothermic and endothermic reaction. The dissolving process. The overall energy change in dissolving is always equal to the total of three different steps involved. So we have three different steps involved. We have the first one, the intermolecular forces are broken down between molecules of solute. Okay? So this type of reaction is considered endothermic since there is uh, an absorption of heat. Intermolecular forces are broken between molecules of water. When this happens, it is still considered an endothermic type of reaction wherein the particles of solute still absorbs an amount of energy as it is dissolved in a solution. Bonds from between molecules of solute and water, however, is using or is exhibiting an exothermic type of reaction. Why? Because in the process, when a solute, which is dissolved in water, and its particles are attracted to the particles of solvent, heat is released in the process. Therefore, when heat is released in the process, we consider this type of reaction as an exothermic type of reaction. This is a classic example of a diagram showing the three different steps. For example, at the start, we have the solute and the solvent. The solute and the solvent in the process, once combined together, will be attracted to the particles of each other. In the process, when a solute and a solvent are attracted to each other, the solute-solvent attractive forces will be formed. When the solute-solvent attractive forces are formed, this results to what we call an exothermic type of reaction, wherein we are actually releasing heat. Again, heat here in this type of reaction is released. Here are the different types of substances. And when we talk about their solubility in water, for example, we have ionic compounds. Ionic compounds are always crystallized and are always electrically charged, meaning it contains both the positive and the negative charge. The ions of the ionic compounds are easily combined with the molecules, for example, of water. So the water molecules, together with the ions coming from ionic compounds, are easily attracted. And when that happens, ionic compounds are often soluble in water. What about molecular compounds with nonpolar molecules? Molecular compounds with nonpolar molecules are not soluble in water. Okay? What about molecular compounds with small polar molecules? Molecular compounds with small polar molecules are usually soluble in water. In the dissolving process, the overall energy change in dissolving is equal to the total of three different steps involved. If more energy is released than required, the overall dissolving process is again what we call an exothermic type of process, wherein the substance will dissolve on its own by absorbing an amount of energy. Or sorry, it's not absorbing an amount of energy, but instead releasing an amount of energy. If energy is released than is required, the overall dissolving process, on the other hand, is already an endothermic reaction, which means this is where the absorption of heat energy occurs. And when energy is absorbed in the process, the substance will not dissolve on its own and it needs heat already. That is why it requires the absorption of heat. The dissolving process would also require or is also determined in terms of the degree to which solute dissolved. Deep, okay? So the degree I mean to which solute dissolved depends on the strength of attraction between the following. We have the solute particles, we have the solvent particles, and the solute solvent particles. So these are the three different factors that determine the strength of attraction. Okay. So particles collision or particle collisions are also necessary for reactions. Most reactions are very slow if the reactant particles are not dissolved in water. Dissolving in water allows the solute particles to separate, disperse, and collide with solute particles. And this will basically allow the dissolving of chemical reactions to occur in a faster rate. That's all for today. Thank you. This is Flip Lectures in Chemistry.